Hello friends, in this video we are going to discuss how to reduce the threshold voltage Vt. So before going to reduce the threshold voltage Vt, let us discuss why a small value of threshold voltage is needed in the case of E-only MOSFET. The first advantage of smaller threshold voltage is that it helps the E-only MOSFET to operate for smaller supplied gate to source voltage. The second one is that it increases the compatibility of the device. And the third one, advantage for smaller threshold voltage, that it reduces the switching time of the device. Now, these are the advantages that we can achieve if the threshold voltage should be minimized. So, before going to the procedure to reduce the threshold voltage, let us see what are the parameters that defines the threshold voltage of E-only MOSFET. That is the equation for E-only MOSFET. So, equation for Vt for N channel E-only MOSFET, sometimes this N channel E-only MOSFET is also termed as NMOS. So, NMOS means N channel E-only MOSFET. So, now we will see the equation of Vt for NMOS. In that case, the Vt is given by the following equation, that is Vt0 plus gamma root over 2 phi f plus Vsb minus root over 2 into phi f. So, this is the equation that determines the threshold value for the NMOS, where the gamma value gamma value can be written by root over of 2 QNA by epsilon divided by COX, and where this COX can be written as epsilon OX by TOX, and we know that COX is the capacitance of the oxide per unit area. So, in this form the gamma value can be written. Now, the Na is the doping concentration of acceptor in p-type substrate, and gamma is determined from the fabrication procedure and the phi f is the Fermi level voltage. Typically, the Fermi level voltage is of the order of 0.6 volt, and Vsb is the substrate voltage or Sometimes it is called as body voltage, and VTO is the threshold voltage when the substrate voltage is 0 So these are the parameters that will determine the threshold voltage of a E only MOSFET for NMOS. So this is the main equation of the threshold voltage for NMOS. Now we have to decrease the value of this threshold voltage. So small variation in the substrate voltage, we can see from this equation that if this substrate voltage has a small variation, then it will give a small variation in the threshold voltage also. So there are many ways by which we can control or we can reduce the value of the threshold voltage. So the procedure by which the threshold voltage of the NMOS can be reduced are the following. So the procedure to reduce the threshold voltage are the following. The first one will be reducing the doping concentration, that is Na, in the substrate. The second one, by increasing the COX value, that is the oxide capacitance per unit area value. Similarly, by reducing the thickness of the oxide layer, that is TOX. And the next one is by replacing the aluminum plates or the metallic plates with the polycrystalline silicon material. The fifth one to reduce the threshold voltage is by using the ion implantation method. At present, the technique is outdated. So if we use the ion implantation method in doping the N-type region, then the threshold voltage can be reduced by a significant amount. So these 5 points are the procedures to reduce the threshold voltage for a NMOS transistor. So in this way, we can reduce the threshold voltage of a NMOS transistor. So after this, let us see what is the body effect of a E only MOSFET or NMOS. That means if we look at this equation of Vt, in this equation we can see that the threshold voltage is controlled by the substrate voltage or the body voltage. That means we have got another one means by which we can control the threshold voltage, and that is the substrate voltage or the body voltage. So we can say that the threshold voltage Vt is now dependent on the substrate voltage or the body voltage Vsb. That is, small variation in substrate voltage or body voltage Vsb will give small variation in threshold voltage, this small variation in the threshold voltage will give a small variation in the drain current, that is ID, because ID depends on the threshold voltage and threshold voltage depends on the VSB, that is the substrate voltage. That means now we have got another way to control the drain current. So we can say now the body voltage, that is VSB, can be used to control the drain current ID. So this effect of the body on the drain current of the MOSFET is called as the body effect. So during this body effect, this is the second means by which we can calculate the ID, like the body is now working as the second gate terminal of the MOSFET, and during the body effect we can control the ID by two means. The first means we can control the ID from the VGS, and the second way is by the body effect. So this is all about how to reduce the threshold voltage of a MOSFET. Thank you.